Welcome back to another video of the channel. My name is Julio. Thanks for tuning in. Before we get started, like, subscribe, hit the notification button, and let's get down to business. So today we're going to be talking about iBGP and what does iBGP actually stands for. And we're also going to be talking about route reflectors and what's the purpose behind them. Let's get inside the details. So iBGP stands for Internal Border Gateway Protocol. Is an interior routing protocol that allows routers within an autonomous system to exchange route information. It is used to ensure that all routers in the same autonomous system are aware of each other's routes and can make decisions about how best to route traffic internally. So let's go ahead and talk about split horizon, which is one of the rules on iBGP. And split horizon in iBGP by default, a router will not advertise a route learned from one iBGP peer to another iBGP peer. And this is because iBGP does not modify the AS path attribute. And if a router advertises a route with its own AS number in the AS path, it could cause a routing loop. To overcome these limitations, one of the options that we have is to use route reflectors. The route reflector allows all iBGP speakers within your autonomous network to learn about the available routes without introducing loops. Let's give two examples. Let's start with iBGP without split horizon. Let's say router 1 was configured with a new network on the BGP instance that actually triggers an update to router 2. Router 2 sends it to router 3, and then router 3 sends that update back to router 1. Remember that router 1 was the one that actually originated that first update with the new network, but it's already running on his side. If he receives an update regarding a network that is actually running on his side, consequently, it's gonna provoke a routing loop, and that's not what we want. So that's why split horizon is so important. In the next slide, you're gonna see iBGP with split horizon. And as you can see, router 1 sends an update to router 2, but router 2 does not send that update to router 3. All right, let's dive into the lab scope. Configure BGP peering between routers, advertise all networks via BGP on router B and router C, verify routing table on router B and router C to verify if you are seeing the networks that they're advertising to each other, which in this case, you not will see them yet. We're going to configure route reflector on router A, and we're going to verify again routing table on router B and router C, and verify if you are indeed seeing now the networks that both routers are advertising. So let's dive into the diagram. Router B are going to have two networks that are going to be advertised via BGP, and those networks are the 10.0.0.0/24 and the 10.0.1.0/24. That update is going to be sent to router A, and router A is going to receive it. And you're going to be able to see those networks on router A, but router A is not going to forward that update to router C because of the split horizon rule. And that's going to be overcome with the route reflector configuration that we're going to do later on. And then on router C, we got two networks also that are going to be advertised via BGP with the 10.1.0.0/24 and the 10.1.1.0/24. Now that I have explained the theory behind it, without further ado, let's get inside CML and let's get started with the configuration. What we're gonna do first is we're gonna configure router B with the corresponding interfaces and IP addresses. All right, so now we're gonna jump into router A and we're gonna configure the WAN interfaces with the corresponding IP addresses. Now we're gonna jump into router C and we're gonna configure the loopback interface and the WAN interface with the corresponding IP addresses assigned. All right, so we're back on router B. What we're gonna do now is we're gonna configure the BGP instance with the autonomous system 65000. We're also gonna configure the neighbor, and we're also gonna configure the networks that are gonna be advertised. Okay, so we're back on router A. What we're gonna do now is we're gonna configure the BGP instance with the autonomous system 65000, and we're gonna configure the neighbors. We are also gonna advertise both one subnets via BGP. All right, so we're back on router C. We're gonna configure now the BGP instance with the autonomous system 65000. We're gonna configure the networks that are gonna be advertised via BGP, and we're also gonna configure the neighbor. All right, let's do a show IP route. And as you can see, the networks running on the loopback interfaces on router B are now reaching router C. And this is because of the split horizon rule. So let's go to router B and let's do the same command, show IP route. And as you can see, the networks running on the loopback interfaces on router C are now reaching router B. Let's do a show IP route on router A. And as you can see, all the networks being advertised from router B and router C are reaching router A as expected. We're gonna go ahead now, we're gonna configure Route-Reflector client on both neighbors. Once we complete the configuration regarding the Route-Reflector on both neighbors, it's gonna do a reset regarding the BGP session. Now we're gonna go ahead to router B and we're gonna do a show iBGP. And as you can see, both networks being advertised from router C are now reaching router B. As you can see on the show IP route command, we can see that both networks are reachable via 192.168.1.6. And this is because when you apply the Route-Reflector client command, it actually states that that network is going to be reachable via that IP address, which is the IP address running on the WAN interface on router C. If you recall, on router A, before we arrived to this point, I advertised both WAN subnets from router A to router B and C, so that way they know their WAN interfaces and how to reach them. And as a conclusion, you can reach the subnets running on the loopbacks. This is the mechanism that iBGP uses to advertise networks without causing any routing loops. All right, so let's jump into router C and let's do a show iBGP. And as you can see, the networks running on the loopbacks on router B are now reaching router C. Let's do a show IP route, and as you can see, both networks are there as well, and they're reachable via 192.168.1.1. All right, let's do a ping to the 10.0.1.1, and using this router's loopback 0 as a source, and as you can see, it replies. Let's jump into router B and let's do a ping test to the 10.1.1.1 and using loopback 0 as a source on this router. And as you can see, it replies back as well. If you like the content, please give it a like. And as always, this is Julio. I'll see you in the next video. Peace out.